Hi, Tita Buxton here. Today I would like us to continue the preparation of bills of quantities. So first of goods, we have done some items including columns, and today I would like us to undertake what we call estimation for the beams. If you'd be wondering, how do we manage to do beams for a high-rise building or a multi-story building? For instance, the one that we are working on. So today I would like us to look into that, estimate, or do what we call the takeoff, if you so wish to refer to it that way. So straight to work. The drawing that we are using here for my new viewers, as usual, it's found on the community wall. For my returning viewers, up to this point, you are aware that we are doing this process by process. For the new viewers as well, the catch-up videos will be attached to this session, worry no more. So let's go on. How do you undertake the taking off of a multi-story building? Straight to that. For our bills of quantities, of course, we are using Excel to do our calculations. That is a software that is readily available, and that is why we even chose to use it. Go to your plan. I will always prefer that there are some engineers that have given the identification of those beams. That is normally a plus. It's normally an easy way to use those identifications of the beams that have been given. If at all the identifications have not been given, then I would urge or recommend that you use the grids for the beams, so that once you've gone through one or you've taken the measurement for one of the beams, then there is no point or there is no way that you're going to repeat that very beam. So at the side, as usual, this is where we do our takeoff. Just to the side, this is where we do our calculations. So I would like us to see how we go about that. The very first thing that you do once you have your drawing is for you to consider, for example, I like us to start with from grid 1, okay? Grid 1, so that we move along that shorter span instead of the longer span. So it's easier to do it that way. So I would like us to start from grid 1, and let me just zoom in my drawing so that you are also able to see what exactly is going on. That said, at grid 1 we have a different type of beam, and because you can see there are beams that are indicated as TB9, we have TB3, we also have TB11 and so on. So the first beams, I'm not going to take them in order, but instead, if I go through, for instance, I'm going to start with grid 1 and then moving along A1 to H1, okay, so that I move that in order, and then to prevent me from avoiding or repeating or skipping some of the beams that I should take off. So this is what we do. Just to the side, I'm going to make a list for the beams, okay? So in this point, I'm going to have an ID, or rather, let me just title this to make it to be called a beam schedule. Yes, I always prefer that you make this schedule so that you do your work in order without having to skip any of the items or any of the elements. So this is a beam schedule. The first column is an ID, where we just indicate this is this, or the number or the name of that beam in short. And then after that, then I can do what we call the size, okay? So as usual, size here, I'm going to have two columns beneath it, where I'm going to have the length and also the width for that particular beam. So that is 1, that is 2 for the size, that is okay. Then I do the third column. For the third column, I would like to have the length of that particular beam, okay? And one of the reasons that you always want to identify your beams according to the name they have been given is because at times the reinforcement for those particular beams are not the same, they are different. So in that case, when you put them together, you might realize that you're going to have an assorted sizes, yet the reinforcement that they have are very, very distinct from one another. So the first one we are starting with at grid 1. At grid 1 is TB9, and I'm confident that you can see TB9. TB9 from grid B1 to C1, okay, along grid 1, but then at B1 C1 we have TB9, okay. So this is TB9, that is what the identification is. For the size, it's 450 by 200, okay, 450 by 200, that is the size of that beam. Then what about the length? So let's find out what the length is. So normally this were another point that needs to be explained properly. There is no deduction of the junctions of the beams or the points of intersections. But then you won't repeat. For instance, if I'm taking along the grids on the lateral grids, then it means if I'm taking them complete length, for instance here, I want to take them complete lengths. That means you can see B1 to C1 are along the centers, but I want to take all those that are going along the lateral grids to be taken full. But then now I'll have to remember that when I'm taking the one along the longitudinal grids, then I have to take them within those particular intersections. Actually, for the purposes of additional work that you normally do when you are doing that intersection point, then it's normally not harmful, or it's normally recommended that you just take them complete without having to consider those intersections, okay. So once I take the one along the lateral latitude grids to be taken complete, I also take the ones that are to the longitudinal grids also complete. So that is what we shall adopt. So for the length of this is equals to, as we can see here, is 3199, but then now these beams are 200 wide, so it means I'm going to add 100 on each side, okay. So that is 3199. Then I will add, or rather I can just use meters direct, 3.199, and then you add 0.1, okay, that is half of one side and then half of the other side, okay. So that is what I find. Then this is 0.45, and then this is 0.2, so that I have everything moving on in meters. Alright, so that is TB9 complete. I want to finish everything along grid 1, then I move to the next grid. Then another one is TB10 as well. The size is the same, that is TB10. Size is 450 by 200, so I'll just copy that to that point, and then I also copy that there. So I want to get what the length is, okay. So for our length, you can see it starting from this is a grid this grid G1 to grid E1, okay. So I want to get what that length is. So this is if I zoom it in well, you can see this is 400 plus 200 also at the centers, okay. So I would like to have it to the extreme ends. So this is 2, then you add 0.4, and then you add 0.1 times 2, okay, where 0.1 are halves of those beams on either side. So the total length is 2.6, okay. Then I move on, I go to grid 2 because I want to take them, as I've said, very much in order. At grid 2, the first one is TB7, okay, TB7. Actually, let me just include another column here, and the column is for the number, because you might find that they are typical, or they are more than, you might find that there are more than one number of column or beams of the same length. So I want to have it here as the number. So in this case, this one so far I've not got any number, so in case I find identical ones, then I'll just insert there. So this is TB7. TB7, I can also zoom it in along grid actually it's way half between A1 to B1. Okay, so as usual, whenever you find that whenever you find that one of the dimensions has not been indicated on the structural drawing, and because you have to read those drawings in conjunction with one another, then you can check from the architectural drawing. So between grid A1 and B1, the beam that I'm looking for is this, where my cursor has been placed. And when I zoom it in well, I can see that particular dimension is 0.6, and the 0.6 is exclusive of the external beam. So it means I'm going to add the external beam of 200. Okay, so I hope you can see what I've just zoomed in. So we go back here, and to this point, A1 B1, that is the one that we are talking about. So we've seen it's 0.6. Now the size as well, I can't see it indicated, but then we'll check on the details if it's there in terms of that size. The number, not yet, we've not yet found if it's more. So for the length, we've seen it's 0.6, and then we add the 0.2, which is to the external part. Then we move on. The next is TB3. Let's see what we have for TB3. TB3 size, let's see if the size is there, for 50 by 200. Okay, that is 0.45, and then this is 0.2. For the number, we are not sure whether there will be more of them, so we just continue. So for the size, for the length, that is 1.1 and then 0.7. Okay, so we'll add 1.1 plus 0.7. That is complete. That is TB3. So we proceed and see what next. We also have another TB7 along the very grid. Just zoom it in. You can see there's another TB7 on this point here. So this one is similar to the one to the opposite end. Yeah, actually you can see it's 0.6. Okay, so TB7, we have two of them already. So as usual, just use I. I'm using symbol I just for counting, and of course I will tally them once all the numbers that I think should be having the same dimensions are complete. So those are two numbers. Then I move on to the next. That is grid 2 is complete. The next grid is grid 3. Okay, so along grid 3 we have TB13. You can see the TB13 for 50 by 200. Okay, that is TB13, and it's also the same size, so just copy this, and then for the number we'll tally that later on. In terms of the dimension or the length, it's 1.1 by it's similar to the one we've just taken off, the TB13. Actually this is TB13, not TB3, the one that we've just done previously. So the TB13 and yes, and actually they are the same, so it means these ones are going to be 2. Okay, they are going to be 2. So the TB13 and TB13, they are of the same size and same dimension. So we've got 2 of them so far. We'll proceed along grid 4 now. At grid 4 we have TB11. Yes, you can see the TB11. So I'll have TB11 here instead of the TB13 there. And TB11 size is the same. Okay, and for the length, let me just zoom it in. For the length, it's coming from H1 all the way to D1. So I need to add the dimensions that are along that path. So this is 0.6, add 0.4, then you add 2 meters, then you add 0.7. Okay, 0.7 is the last dimension over there. but then I need to add the two extreme ends, that is 0.2 times 2, that is 0.2 on one end and 0.2 on the other end. That gives me a total of 4.1. So I just zoom it out so that I also check keenly the next one. Along grid 5 now is the next. Grid 5 we have TB12. Okay, so this is TB12 going along grid 5. The size is the same, 450 by 200, and then the number we'll find out that later. Yes, for now of interest, let's calculate the length. It's coming all the way from grid A1, and then it moves to grid D1. Okay, grid A1 to D1. So let's add the dimensions. So from grid A1, that is 1.2, then 3.199, and then we add, it goes up to D1, so I add 1.1 and add 0.1 for half of the beam on extreme ends times 2. That gives me a 5.699. Good. So along that grid there is no more beam there. Then I go to grid number 6. So at grid number 6, what we have is TB14. If I zoom it in, you'll be able to see that. TB14. Alright, the size is the same, 450 by 200. For the number, I'm not sure, we'll find out later. And then for the length, it's from grid D1 all the way to H1. Okay, so is equals to, from D1 I will add 0.7, then you add 2 meters, then you add 0.4, then you add 0.6. okay, and of course I will also add the extreme edges, that is 0.1 times 2, giving me 3.9. so that is TB14. Alright, that is complete. I go to grade 7. Along grade 7 we have TB12. I had another TB12, but let me confirm if the lengths are the same. Yes, actually it's they're identical. You can see TB12 along grade 5 was from C1 to A1, and then yes, that is what I did. Then another one is also along grade 7. They are the same, so it means for the number here we have 2. Okay, so that is simple as such. We move along and see which one else is to be added. That is grid 7. Then you go to grid 8. Along grid 8 we have TB11. If I zoom it in, I'll do you justice to see what we have. TB11. So at TB11 we have the same size, so just copy that, then for the length, that is what we need to look at or find out. TB11, it's coming all the way from grid H1 to grid H1 to grid D1. okay, where we added D1, that is 0.7 plus 2 plus 0.4 plus 0.6, so it's the same size as what we've done here. So to make our work easier, we'll just copy what we had already calculated for TB14. That is TB11 is done. We go to grid 9. At grid 9 we have TB13. I'm guessing we had TB13 as well. Yes, somewhere here. And you can see the sizes and the lengths are the same, all originating from grid E1 to grid C1. Okay, so that is what is happening there. So it means these are 3, so I'll add another one here. Okay, that is how we do the tally one by one until we complete everything. That is grid 9. Then we go to grid 10. Okay, so along grid 10, what do we have? Alright, so for the grid 10 we have TB7. Remember, we are done TB7 somewhere. We just need to confirm. Actually the lengths are the same. You can see TB7 on this side and TB7 on that side, all on the 4 edges. They are of the same, from the same grid. So we'll add 2, okay, for one at this end and one on this opposite end. So we'll add 2 more beams here, okay. Then along the same grid 10 we have another TB13. So TB13, we also add another TB13 here for the counts, and that is complete. We go to the extreme grid 10. The exterior grid 10, we have another pot, another beam, and that beam is TB9. Okay, so TB9 seems that it's also here. We have done it before, and let's see how it is. So the sizes, we had it going along, this is 3.199, and then yes, 3.199, and then we add the 0.1 times 2. Okay, so here TB9 we have 2 of them, okay, the one that we did at grid 1 and now the one that we're doing here at grid 10. So those are 2. Then move on the same grid, we have another one here. This is now TB10. There seems to be another TB10 that we are done. Same size, same dimensions. So we have TB10, 2 of them as well. Okay, so that is how we go about that. So after we've finished all along the lateral grids, then we now move along the longitudinal grids. So if you maintain that kind of orderliness, then you are not going to miss out on the beams that you should be taking off, or repeating or leaving them out to the worst case scenario. So we move to grade H1, or rather we can start from grid A1 and then we move all along the way for the longitudinal grids till they are all completed. Alright, so I'll just zoom it in so that we take it off together. Along grid A1, the first one is TB1, okay, and I can't see another TB1. We are done, so we'll start with that. So we go to TB1. TB1 is of the same size, 450 by 200, so we have it copied there. For the dimensions, it's if I zoom it in, from grid 5 to grid 7. Grid 5 to grid 7, so that is 1.2 times 2 is equals to 1.2 times 2, and then we add 0.1 times 2. Okay, so we have it. That is TB1. Then we go along the way. There is no more other beam along the same grid, so we go to grid the grid between A1 and B1. You can see there's some beams there, okay, and that is TB2, 2 of them. So we have TB2, that point, and the sizes 450 by 200. So if you have a look at my cursor, you'll be able to see the one that I'm pointing at. So the same size, just copy that here, copy it here, then we continue. Now for the length, we are going to add from grid 2 to grid 5, okay, grid 2 to grid 5. So we add that equal to, from grid 2 grid 5, so we have the first one is 2.1, then we have 1.1, then we have 1.2. Alright, then we add the 0.1 times 2. Okay, so that is how it goes. So to be TB2, we have noticed that there are 2, okay, all of the same. Let's confirm if they have the same length. So this is 3.2 plus 1.2 should give you 4.4, so the total is 4.6. so they are of the same length. So in this case the number is 2. Okay, so we move on quite fast. After grid the grid between A1 and B1, the next is now on grid B1. Okay, so grid B1 we have a TB7 again, so it means we'll add here we'll add another one for our tally. Then we just follow it all through quite slowly. Then the next is to the upper end, another TB7. So we add another number here for the TB7. Okay, well done. So we move on. That is B1 complete. B1 is complete. However, there is another beam here which we are missing out. Yes, just beside grid B1, okay, there is another beam here called TSB1. Okay, it's not entirely along grid B1, but it's just beside it, so we have to include it as well. This is now TBS1. Okay, TBS1 is of a size of 150 by 400. Okay, 150 by 400. So this is 0.4, and then this is 0.15. Okay, so the 450 is the depth, and then of course 200 is the width. Okay, so TBS1, the length for that beam is now 1.2 times 2, then plus 0.1 times 2. Yeah, you can see it's the one for the staircase, so it's 1200 on either side, and then you add as well that those external extreme ends, and that gives us 2.6. So the next is along grid C1. Okay, so along grid C1 we have TB3. I can see TB3, and also to the upper side is also another TB3. So you confirm if we have TB3 anywhere. Doesn't seem to be, we haven't done it somewhere. So this is TB3. What is the size for the TB3? 450 by 200. So there is no harm when I copy that, bring it here, and then size number, of course we've seen there two, and then now the length of one of them is going to be from along grid this now grid 1 to grid 5. So grid 1 to grid 5 is equals to 0.6 plus 2.1 plus 1.1 plus 1.2 plus 0.1 times 2. Okay, so that gives us a total of 5.2. There are two of them, so that is complete. So after grid C1, then we go to grid actually, yeah, that is grid C1. There is another grid D1. So go through along grid D1, you'll find there is a TB4. Yes, quite long. TB4, it's here. So let's see what we have for TB4. So at TB4, it's going from grid 4. Okay, just follow through with my cursor, all the way from grid 4 to grid 8. So we need to add grid 4 to grid 8 dimensions. So the very first one, okay, of course we can't forget the size. It's 450 by 200. 450 by 200. So it's equal to TB4 is equals to 1.2. Then we add another 1.2. Okay, that is from grid 4. Then we add, okay, so grid 1.2 seems to be many, all the way from, okay, 1 2 3 4. Actually there are 4, that is up to grid 8. And then of course we add the 0.1 times 2. Okay, so all beams, I explained that, and I would emphasize that you take them all through. Okay, from the external surface, all through to the external surfaces on either directions. Okay, and the reason is, normally as you cast the beams along those particular intersections, you will need to have more input in doing those particular joints, rather than the average normal lengths and that is why to cater for that extra that additional cost, there is always not harm to have that or not deduction of those particular intersections. Okay, so we've done that. We've added the 2. TB4 is also included. That is TB4, it's only 1. Alright, okay, if we find another one, we'll have to adjust. So let's see from that is TB4, that was along grid D1. So we go to grid E1. From grid E1 is TB5. You can see TB5, the one that I've just zoomed in. Okay, so TB5 here. So for the TB5, the size is same, 450 by 200, and then dimension. The dimension now goes all the way from grid 1 to grid 4. Grid 1 to grid 4. Alright, so that gives us 0.6 plus 2.1 plus 1.1, and then you add 0.1 times 2. Okay, that is TB5. Then we go upwards with it. We have another TB5 on the upper end, the same dimension. Okay, same size. You can see there is a 3.2 plus 0.6, that should give you 3.8 plus 0.1 times 2, that gives you another 4. So we have 2 of them here. Alright, that is nice. Then E1 is complete. Then we go to grid F1. Grid F1, we have TB6. Okay, TB6, if I can see it properly, they are of the same length as TB4. Okay, so we just copy this, what we had done for TB4, paste it here, and then edit this to become 6. Alright, so that is that easy. That is TB6 is done. Then the next is along grid G1. Grid G1 we have TB7. Okay, we have TB7 here from one point, then another TB7 to the top. So we will add 2 TB7. Okay, so where is TB7? Another 2 there. Okay, so that is alright, so we have done the TB7s. TB7s are complete. Then that was grid G1, and we only have those 2. So the next is grid H1. So for the grid H1 we have this TB8. TB8 is complete all along that length. So that is the last one. We include it here. The size is 450 by 200. For the length is from grid 10 to grid 2. Grid 10 to grid 2. So we add. Okay, the complete length is from grid 1 to grid 10, the other external grid 10. So what we'll do, we'll take it complete, the 12.4. Okay, we'll take 12.4, and then we subtract. We'll less 0.6 to the top is 0.6 that needs to be subtracted, and then to the bottom is also another 0.6. So that is a total of negative 1.2. Okay, so 12.4 minus 1.2 should give us 11.2. So 11.2, and then we add the 0.1 times 2 for the exterior surfaces. So we have a total of 11.4 for the length for TB8. So that basically, then we now let's do our tally so that we're complete, we are done with this. So this is 2, this is 2, and then this one let's count. So that is 1 2 3 4 5 6 7 8. This gives us 8. Then this gives us 4 from what I can see. Okay, and of course these other ones are 1, this is 2, this is 1. Okay, so 1 I can just drag it here. Then this is 2, this is 1, this is 2, this is 1, this is 2, 1 and 1 as well. Perfect. So it means we already have a beam schedule with all the dimensions, all the beams shown, the sizes, and so on. So what remains is for us to get the volume. Okay, so let's do this. For us to get the volume, normally beams are supposed to be measured under the slabs. That is one concept that you have to remember. So we go to the details. Okay, of course the plan was giving us the length or the layout generally, but then actually the details are here just to the side. So the details, when you look at the details, I would like us to check what we have. Yes, for instance, this is one of the beams. This is TB11. So TB11, you can see the 450 is inclusive of the slab, because you can see there is 150 slab and then there is 300 for the beam. So for you to get the quantity of concrete for the beam only, then it's supposed to be 300, not 450. Okay, because that slab is 150. And of course you can always confirm. Just get the slab, get where you have the floor slab, and see what the thickness for the slab is. In this case the slab is 150. Okay, so it means for those that are 450, we need to subtract 150 for the slab. Okay, so in this case the one that we have as 450 is going to be 450 minus 150. That gives you 300. And also when you look at the details, it's showing you there is at the top you have 150, which is for the slab, and the beam just beneath it. So this is going to be 0.3. Okay, so just copy the 0.3 there, 0.3, and just drag the 0.3 all the way up to that point. Okay, I don't know why this is not coming. Good, so we have 0.3. For the TBS1, it's an exceptional case, so we are going to look at it, why it's exempted from the rest of the other beams, because you can see its size is slightly different. So just copy that. I mean, this is 0.3. Yes, so let's see the detail for TBS1 so that we see what kind of beam it is. So let's get the T. Okay, so looking at the detail for TSB1, you can see that it's 150 by 400, where 150 is the depth and 400 is the breadth of that beam. The depth is 150 and the slab is also 150. Okay, so one thing that you have to note, that there are two scenarios here. One of them is there is no extra concrete quantity for that particular beam, because that beam is a slab beam, you can call it that way. So the very thickness, all the thickness that is for the beam is the same thickness for the slab. So it means we don't have an additional concrete volume for the beam, but then it has got its own reinforcement. So that is what we are going to find out in when we get to calculation of the sizes. I mean the concrete, the reinforcement quantity for that particular beam. Okay, so in this case it's 150, but then we are not going to now measure the concrete volume. Okay, so in this case, for the concrete, let's just have it an X, so that we don't include that particular beam. And of course the rest of the beams are 450 for the depth and 200 for the width. This is where you can always see the details of those particular beams. Of course, if you're not sure of how they have been named in terms of the depth and the width, you can always check on the details. Okay, for instance, here you can see it's 450 by 200. So the 450 is the depth and 200 is the width of those beams. So I would like us to do now the volume, and of course the volume is now easier. We get the size, that is length by width times the length, actually for the area of the face, and then times the length. That is how you get the volume, and then you multiply by the number of those beams. Okay, so that is how you go about that. So I will drag this actually TB7. I hadn't put the size. Let me get TB7 where it is, so that we have the size. Yes, TB7 here is also 450 by 200. So that means 0.3 times 0.2. So let me drag the formula so that it's repeated to the rest of the items. So it's that easy. You simply whenever you have that positive sign, the dark plus sign, then you drag it. It's going to give you the formula, or it's going to drag the formula for the rest of the cells, and then you now have what we call the sum. Okay, and of course, because we have this X here, it's going to make it a little complicated, so we have it for the rest of the items up to here. Alright, so that gives us a sum of that is then we add that is a sum of 6.02 and so on for the volume. So that is an elaborate description, or how you'd go about the volume for the beams. And of course, because this being a multi-story building, you can see it's written here, typical floor slab, no actually yes, and beam layout from first floor to fourth floor. So normally it's always very, very important that we go you check, you count those particular floors. Okay, then we'll multiply by this by what we have here, because we are dealing with a multi-story building. So we have the volume for just one floor. Okay, so it's also important that we now multiply by the rest of the floors, so that you don't leave any of them out. So this is what we do. Just want to count what we have. Alright, so the ones that we've done are first floor beams. So this is 1 for the first floor, 2 second floor, 3 for the third floor, 4 for the fourth floor, and 5 for the fifth floor. Okay, yeah, so being that the beams are from first to fourth, then first floor, second, third, and fourth. Fourth also have beams at the top level. So we have to multiply this volume that we've got times 5. The advantage is that they are typical. So if they are typical, just get for one floor and then you multiply by the number of floors. If they were different, then you'll have to do the beams independently for every floor. and you'd imagine how hectic that is. Yes, in some instances you find that the floors are not typical, and also the layouts are different, so you have to do them one by one. All advantage to us, they are typical, so just do for one comprehensively the way we've done, and then you multiply by the number of the floors. So the beam concrete quantity is 31 cubic meters. Okay, so that is what we have here. So that brings us to the end of our coverage, where we are doing comprehensive calculation of quantity of concrete for the beams of a multi-story building. So any question that you might be having, as you've always done, just put it at the description, then we'll answer to it as soon as possible. I want to appreciate you so much for watching up to this point, and I'm confident that you have been learning. The comments received at the sections are always very encouraging, and I'm urging you that please subscribe to this channel. You don't want to miss any of the upcoming videos. Thank you very much. Have a great time till we meet again in our next session. Bye bye.